Okay, so we know how to graph using these transformations, but what if we want to go the other way? What if we have the graph and we want to find the equation from that graph? Well, it's the same, using the same knowledge here. You got to know, what graph you're dealing with, and then you look and see, well, what's the transformation, and then that will probably help you determine your equation. All right, so on the handout there, let me draw it up here. Number one. Let's see, that's up at 3, isn't it? All right, so I've got this shape here, which hopefully that reminds you of the x squared graph. And so that's our common function here, is the x squared graph. But there's a transformation going on, isn't there? How is that graph I have in number one related to the x squared graph? Well, it looks like it's the x squared graph. It's been shifted up 3 units, right? Well, if that's what we got, what's the equation going to be? Well, it's an x squared graph, up 3. To get it to go up 3, what do I do?
Minus 3.
Don't overthink it. Yeah, the up 3, up or down 3, it goes like you would think it does. Up or down goes the same as you think it does. It's y equals x squared plus 3, yes. Plus 3 on the outside. Right? Yeah. Now number 2, we've got a different function, don't we? We've got the v-shape function. Looks like the corner, the vertex, is over here at -4. Y-intercept's positive 4, but so what's the common function here?
And the absolute value.
Absolute value. Absolute value of x. What's the transformation? Well, that one looks like it's gone, because the absolute value of x, the corner is at 0, 0, and so now the corner is at -4. That's shifted it 4 back, hasn't it? 4 to the left?
Mm-hmm.
So how do I get the absolute value of x shifted 4 to the left?
Absolute value of x plus 4 squared.
Okay, so to get it to go left, right or left, it's got to be on the inside, doesn't it? And left, maybe the opposite of what you think. It's got to be plus 4 on the inside. That's right. So it'll be y equals the absolute value of x plus 4. Yes?
Mm-hmm.
Believe that?
Does it need to be squared?
Is this one squared? Nope. The x squared graph looks something different. This is just the absolute value.
My bad.
All right. What do you got on number 3?
Cube graph.
X cubed. Let me draw it up here real quick. Looks like we've got the little squiggly part at 3 and 2. Yeah. That's y equals x cubed. Shifted how?
-2.
Well, it's 3 to the right.
3?
3 to the
I think so.
I got 2.
3 to the right.
Oh.
3 to the right and up 2.
Three.
Yeah.
Yeah.
I believe it's 3 to the right and up 2.
Yeah, that's right.
All right, well, if we know that, then we know the equation. The equation's got to be then, well, to get it to go 3 to the right, right or left is on the inside. And to go 3 to the right, it's right, so plus or minus 3. Minus 3. Yeah, 3 to the right, you need a minus 3. Now, be careful here on that. It's not this. Why not?
Because it all needs to be cubed, not just...
It's got to be on the inside. That doesn't mean on the inside of the parentheses, it means on the inside of the function, which the function here is the cubing. Just because you put it in parentheses, that -3 is still on the outside of the cubing. You see what I'm saying? So it's got to be x minus 3 and then the cube on the outside. And then the plus, the up 2 is plus 2 on the outside. Yes? Do that? Good? All right. Yeah, so number 4, I got a point here made to you. Back to our absolute value, right? So we got y equals the absolute value of x. And so what is the transformation there?
Down 2?
Okay, we got a down
Oh,
2,
it's a negative.
and we got a flip. We got a reflection, okay? All right. Now, let me just tell you here, the order does make a difference. Because the order here is I reflect it and then I move it down 2, right? Not down 2 and then reflect it. That would be a little something else, and maybe I'll do that one here. So it's a reflection and then down 2. So this is probably not quite as tricky, but let me just show you here. So this one I got to do a reflection, and so the reflection, how do I do it? Put a minus in front of the absolute, and then down 2. Well, that's up or down. That's the outside, so it's outside the absolute value, and then down is negative 2. Yeah. All right.
And how did you know to do the reflection before you went down 2?
Okay, so if let's think about that. So what if I did the down 2 and then reflect?
There'd be a space in between, it wouldn't mirror each other.
Okay, so if I go down 2 with the absolute value, puts it here, right? Now, if I then reflect it, remember what the reflection does is it flips everything over. What's on below the x-axis flips up, what's above the x-axis flips down. And so if let me get rid of that. If I reflect it now,
Oh, I gotcha.
that flips over, and so this is now at positive 2.
It's a W.
Yeah, well, it does that.
Yeah.
So you see you get a different, so the order does make a difference there. So just be aware. And it makes a difference on the equation too, because if I do down 2 first, and then I reflect it, well, I'm reflecting the whole thing, so it actually becomes that. So that's not what we got here. Probably if we had that graph, we would say it's a reflection and then up 2, wouldn't it? If we start with the graph. And that's exactly what this is, because if you distribute the minus there, what do you got? Negative x plus 2. So anyway, not to get you too confused there. Just be aware. So this is, for number 4, this is it. Any other question?